So my name's Shannon MacPhee, and I'm a biologist with Fisheries and Oceans Canada. I'm talking about a program today that many people have been involved with for many years, and it's a long-term collaboration between government scientists in Canada and our co-management partners, the Enooyaq, represented by various wildlife co-management boards and community members as well, and a number of scientific collaborators. So there's a huge group of people involved in this work. I just wanted to orient you to where we are. So I'm based in Winnipeg, Manitoba in central Canada, and Enoo's over in Prince Edward Island in eastern Canada right now. And the area that we're looking at is the Canadian Beaufort Sea up on the top in that white square. And just to highlight how spread apart we are, and also that it takes us about 2 days at least to get to from where I am in Winnipeg to Enooyaq, which is the regional center where we work out of. And then if I'm going on to a community, say Tuktoyaktuk on the Arctic coast, then I'll have to drive for another 2 hours on the all-weather highway or take a boat out to one of our field sites. So it takes a long time to get there. And I think people in this group working in the Arctic will be familiar with that. But I wanted to mention it because it's really important to how we work. We spend a lot of time now, especially since COVID, trying to work remotely with our community partners, doing video calls like this, but that time spent on the ground being together is really what makes our work and our collaboration successful. We're talking today about Beaufort Sea beluga whales. So this population is considered to be very large. Our last abundance estimate was based on data from 2019, and there's just under about 40,000 whales based on that estimate. The animals that we sample in our program at least are healthy, but Enoo will talk about how hunter selection factors into that because we're working on a harvest-based monitoring program. These whales it's a transboundary population, so they winter in the Bering Sea in the US, and they migrate over to Canada in the spring through leads in the sea ice, where they form one of the world's largest aggregations of beluga whales in the world in the Mackenzie estuary in the Canadian Beaufort Sea. And that's really important because that aggregation of whales has supported Enooyaq culture and subsistence reliance on the land and the whales for many centuries. The relationship between belugas and Enooyaq is really long-standing and really important even to this day. And I wish we could have had one of our community collaborators come and tell you about how important these whales are to their culture and their well-being, socially, economically, for subsistence food purposes, and to their overall health and well-being. So people are still harvesting about 100 whales per year from the population. There are 6 communities spread out in the region. It's called the Enooyaq Settlement Region. It's a modern land claim area. And there's 6 communities that hunt and harvest from this whale population. And the belugas are a major part of their subsistence food. So I wanted to highlight, because we're in Canada, and we're working in the Canadian Arctic and Enooyaq. In this area, it's a modern land claim area, like I mentioned. So we're operating under the Enooyaq Final Agreement. And under this agreement, there's a co-management framework that was established where territorial and federal governments in Canada work cooperatively with co-management boards established. So some of them, these boards are co-management boards that include Enooyaq and Canadian government officials, and some of them are wildlife boards entirely comprised of Enooyaq community members who make decisions of matters related to wildlife in their own region. So this framework really lays out the way that we can work together and who the players are in a really basic way. And it's something that we can build on over time and have built on to really establish some partnerships and a long-standing relationship of working together. I wanted to highlight here that the Fisheries Joint Management Committee is the Wildlife Co-Management Board responsible for the management of fish and beluga whales, all whales and marine mammals in the Enooyaq Settlement Region. And so they have put together their Beaufort Sea beluga management plan, going back from when their land claim agreement was signed in the mid-1980s. So they're a key part of their beluga management plan is a really robust harvest monitoring system. The Enooyaq adopted some conservation-minded community-based bylaws and this robust harvest monitoring system instead of a quota system. And so this is really critical to how they choose to manage whales in their settlement area. The monitoring program goes back to the 1970s. It started with industry. And then in about 1980, Fisheries and Oceans Canada assumed the operations of this program and standardized the approach to monitoring. So not just collecting the numbers of whales landed, but also collecting some tissue samples to tell us about the sex and the age of the whales, and also collecting information on their size so we could get a better picture of stock metrics. And the whales are sampled on a voluntary basis by community-based monitors located at harvest monitoring sites across the region. So there are a number of people every year out on the ground working with harvesters to sample their whales. So where do we come in as a science team? We've been able to build on that regional and community harvest monitoring program to collect additional samples that will give us more information about the health of the whales. And so our goal is really to characterize the overall health of the beluga population. And we do this really to respond to priorities set out by the co-management boards and the boards at the community level. So we're really trying to be responsive to community concerns and interests. And we try really through all the ways that we work to work collaboratively and to build some capacity for sampling within the region so that community members are collecting those additional samples that we collect as scientists that require a little bit more handling and some training to manage. And we also really work to share knowledge. This is really important to us. So we're sharing our science with the harvesters and the beluga monitors, but they're sharing their knowledge of being on the land, of what they know, of the behavior and distribution of the animals and the health of the whales. And so it's really a back and forth relationship. And I mentioned at the start the importance of really spending time together to create that space to develop those relationships and to make the space and time to learn from one another. And so over time, through this the sampling program that we've been running cooperatively, there's this community that has developed at one of our main long-term monitoring sites, which is called Hendrickson Island. It's about 20 kilometers from the community of Tuktoyaktuk on the Beaufort Sea coast. And in any given year, we'll have the harvesters out landing their whales. We'll have the community-based monitors, a group of various scientists. Often we'll have elders there to sort of teach us how to be on the land and how to interact with one another, and also so that they can be sharing their knowledge and passing that on to youth. And working with veterinarians also. So there's a lot of activity at this site, more than at some other harvest monitoring locations. And that's been really important to our science program and the samples that we're able to collect and the information that we're able to generate from that. And so the best way to learn how to sample a whale is to be at a whale, but we also really try to show people the work that we're doing in many different ways. And so here I'm showing a couple of workshops that have been run in Paulatuk and in Tuktoyaktuk in the Northwest Territories to show people, to try to train people in the sampling methods that we're using in the field. And then people who are interested get hired and come work with us at the field site. Something that has been important for a very long time and is now really hearing this more and more from the community members that we work with is the importance of youth, and they're actually calling youth now future leaders because we're losing elders, and with some of them that knowledge is being lost. And so transferring Indigenous knowledge from elders to youth is really important. And youth are looked at as the future of carrying on traditional lifestyles and traditional knowledge. But they also are so fundamentally important to bridging the gap between the science that we're doing and those traditional ways. They kind of, have their feet in both worlds. And so working with youth has been really important to our program and trying to establish a team going forward. And it's really important to our community partners as well. I haven't really talked about the samples that we collect, but this is a slide that we like to show to say that the harvest monitoring program grew from being, how many whales are landed, and then what are the basic stock metrics that we can get from those landed whales, to really looking at their health from many different lenses. And so here's just a quick overview of what some of those are. And so Enoo's going to talk about the contaminant monitoring and mercury, which is one of the longest running sampling collections for this population. But we've also over time started to work with Indigenous knowledge holders to identify their indicators of health. So what does a hunter see as a healthy whale, and how can we record that information and use that to track potential changes over time? And just, I'm going to hand it over to you shortly, but I wanted to highlight that another important part of working together collaboratively, designing a program together, trying to identify, priorities and research questions, and then address them and interpret that information, really requires us, again, to spend time on the ground talking with harvesters and other community members. And so one thing that we're building towards right now is to have a very large meeting called the Beluga Summit that brings together about 80 Enooyaq community members and about 25 scientists working on different aspects of their health and their population abundance and stock status, to get together and share what we know about beluga whales, bring together our knowledge to sort of establish the current state of knowledge for the population, identify those priorities going forward, and then talk about ways that we could address them cooperatively. And so contaminants are always a priority topic of concern and interest to people. They want to know if the whales are healthy, and they really want to know, are the whales healthy for them to eat? So contaminants will be a big feature at this meeting. And I think then I'll pass it over to Enoo, who's going to be sharing some of that information with you today and with the community members coming up in a couple of weeks at the Beluga Summit.
Okay, everybody. So I'm going to talk about a little bit of our recent findings in reassessing historical mercury trends in Enooyaq, Northwest Territories, and in Alquiat as well. I just wanted to quickly mention a couple things. Kinaubunga, or who am I? I was born and raised in Nunavut. I was born in Iqaluit here on Baffin Island. And I spent my childhood years in Pond Inlet, which is where this photo here on the bottom right is taken. We're out fishing close to Pond Inlet, but both my parents are actually from Resolute Bay, and they actually were outfitters in the 60s, 70s, and 80s. So I feel like it wouldn't be crazy if some of you had met them at some point. I am currently based at UPEI, and I focus mostly on Arctic marine mammal research. We might skip over some of these slides because Shannon did such a good job, giving us an overview. But beluga have a really high site fidelity. They're really high on the trophic level. Only thing above them, polar bears and us, in some regions, orcas. And we're going to be talking about two populations. As Shannon mentioned, there is a really long-term relationship with Inuit and belugas. And we anticipate their arrival every summer, and it's a very exciting thing when the first whales come in the spring or summer, and it really is a form of soul food, is what a lot of Inuit call beluga. Now, we know that if you're a hunter or a fisher or even a farmer, At some, maybe you have some family who are farmers, it takes a lot to assess your food. You're looking at size, the color, the appearance, all this stuff. It's the same thing for beluga. Hunters are really assessing even the behavior of the whale. But you may not necessarily be able to smell how much contaminants are in it or see how much POPs or forever chemicals are in it. This is where Western science really comes in to identify these imperceptible risks. So we really need both. And I know sometimes people are a little bit iffy on like using both, but really it comes down to what we're all in this room for, or this virtual room, assessing wildlife health and food safety. Now, this is just to show there are so many different parts to this beluga monitoring program. And what we're talking about today is really just this top right corner up here, contaminants, specifically mercury. There's lots of different other contaminants they look at as well, but this is just to show this is a really complex, big monitoring program that is doing a lot of cool things, and we're just talking about one component of it today. So we're focusing in on two beluga populations for this portion. Eastern Beaufort Sea, which we're very familiar with now thanks to Shannon, and then the Western Hudson Bay beluga population. They're two of Canada's largest and healthiest populations, and we're going to zoom into one community in each region. And so one of them is in the ISR, the Enooyaq Settlement Region. We're going to be looking at Tuktoyaktuk. And as Shannon said, it was a lot of very similar stuff here, but now we know everything we need to know about the ISR. But in Nunavut, so we wanted to compare this really long-term data set in the ISR to one in Nunavut, because I'm from Nunavut. I wanted to find out how's our beluga doing, because we don't have as long a data set in Nunavut in any community compared to what they have going on in the ISR. So we're looking at Enooyaq here in the Western Hudson Bay coast. It's a few hundred kilometers north of Churchill, Manitoba, and they harvest they harvest almost the most beluga in all of Nunavut. And we're going to get more into that here in a moment. So before we started the work, we had talked with the local HTOs and did some consultations. We asked, do you have any priorities? And they said, yes, we keep hearing about mercury. Can you just tell us a bit more about it? So there is kind of a long-term monitoring program in both regions, but in Enooyaq, it's really sporadic and there's a lot of gaps in the data. And there have been some comparisons done in the past where they're comparing morphological differences between the two populations. And the leading theory is right now, Eastern Beaufort Sea, they're much higher or further north than Western Hudson Bay. And so that might be why Eastern Beaufort Sea whales are actually bigger, like in length, and a bit skinnier than the ones we see in Western Hudson Bay, which are shorter, but are thought to be fatter. So there's some morphological differences that have been observed in the literature in several different pieces. And this is the paper that we always refer back to from 2005. And we know these Eastern Beaufort Sea beluga up in coastal Northwest Territories have the highest mercury concentrations in Canada, well, in the Canadian Arctic. We're not talking about St. Lawrence today. So this is just showing us by years what's the mercury concentrations. And at the bottom here, it says age-related levels of mercury in liver at age 13.1 years. So that's telling us it's extrapolated down. So all of these different ages are coming down to one data point or being extrapolated to that same comparison year. And we're going to come back to that. But essentially, this is what we've been working off of since this paper was published. It was a big landmark paper, and anybody working on contaminants in marine mammals, or maybe especially beluga, would know this paper. So we wanted to combine that with some harvester operations or observations. So IQ, Inuit Kalimatungit, or Inuit ways of knowing. So you might have heard of the terms like reading knowledge or two-eyed seeing. This is kind of the approach that we used. There's not one specifically for the Arctic yet, because ultimately this beluga story, this beluga mercury story, is really, really closely tied to human story. And that's because where are we getting our samples from? We're getting them from people. But this is published, it was published last, is it February now? I guess December, so a couple months ago. And our goal was really to investigate how interpretation of these two data sets from these two communities are impacted when we consider local contexts for harvester preference and local history. So we went back and used a different lens to really look at the same data set then that DFO has been using. So as I said, we did pre-research consultations, found out they were interested in mercury. We did interviews with active harvesters to find out what they're harvesting, how they're choosing to harvest. A validation session, number 3, is really, we did all the interviews. I summarized the interviews and went back to the communities in person and said, this is what I interpreted from all these interviews. Is that correct? So I'm just validating my interpretation of what they said. And then we have presented the results. So we did 15 interviews in Alviat with 15 local knowledge holders, LKH, with 18 local knowledge holders in Tuk in July, August 2022, and our validation session was in February. The data set also goes back to the 70s for historical. That's the spreadsheets. We didn't reassess those samples, but we did also collect new samples in 2020 and 2021, included those. We also made sure that all this information in the data set were complete cases only. So age, length, tissues of interest. We looked at 3: skin, muscle, liver. We did sex segregate them between male and female. And for the new samples, we used CVAS, cold vapor atomic absorption spectroscopy, here at the University of Manitoba. If you want to chat stats, I'd be happy to, but this is where really the magic happened, in my opinion. So of course, we transformed the data, sex segregated. We used generalized linear mix model. We had fixed effects and random effects. And we also did U-tests, but also moods tests, because our data set was actually pretty skewed. So we really looked at medians as critically as we did for the means. We also used age or length bins in addition to these linear mix models. So from the interviews and just a little bit of reading about the history of both Alviat and Tuktoyaktuk, we found out the community of Alviat didn't actually exist until 40 years ago. So most of these Inuit in Alviat were inland Inuit. So they were caribou hunting Inuit, they were fish Inuit, they didn't really hunt beluga all that much. And in the ISR and Tuk specifically, Tuk specifically, they had a really long history of being coastal Inuvialuit. So right there's a big difference, and we did see some impacts of that, which I'll talk about. But this is based off of our interview results. So we have Alviat and we have Tuk, and belugas are born very, very dark gray, and then when they become full adult, they are fully white. So this is just telling us which community prefers which whale. So in Alviat, they actually prefer the sub-adult. It looks almost bluish. It's not quite gray, it's not white. They want these sub-adult whales. And then in Tuk, they want like the big, big whale. Like when you go out deer hunting, you want the big buck. It's the same thing in Tuk. They want the big, big whale, the biggest one there. That's what they want. But there is some harvesting of lesser amount of harvesting for younglings and sub-adults. But in Tuk, it was really a heavy emphasis on subadults with some generational differences. So the young hunters are like, I want the big one, and then the older hunters wanted the younger ones because, like veal, younger whales are softer. So there was a big difference in preference between the two communities. So some quotes here. This is from Paul Iblauk. I like the grayer ones since they're softer and they taste better. I don't dislike the white ones, but the gray ones are better and more tender. And here in Tuck, the older big ones, most hunters in Tuck said like a length 14 to 15 feet, anything under 13 feet, and you hardly get any oksuk or fat. So there was a big difference right there, just talking to the harvesters who were giving us our samples. Almost, I'd say 99% of beluga whale samples from the Arctic are from Inuit, or from these guys. So let's go on a hunt and kind of a virtual hunt and see kind of this in action. So we know this, the younger the whale, the smaller, but there's variation within ages. So even in people, if you see a 13-year-old teenager, there's some taller ones and there's some shorter ones. So there's variation there, even in whales. So let's go on a hunt here. So on our first hunt out, if you're in the ISR, if you're in Tuck, they're gonna get the big one. So boop, we got the big hunt, or the big whale. And then in Alviat, they like the subadult more, so they're like, you know what, I want that subadult. Let's go on another hunt the next day with a different set of hunters. In the ISR, they're still getting the big one, but in Alviat the next day, let's say we had a younger hunter, they want that big one. ISR, same thing, the big one again. And next, on their third day in Alviat, we went out with an elder or somebody who has an elder within their immediate family, and they requested a smaller whale, so that's what we got. So here we're already kind of seeing a bias towards different whales, or it's almost an even distribution in Alviat, but in the ISR, it's heavily skewed towards these big whales. And we can see that preference, hunter preference or harvester preference, in the data set, like extremely significant age and length difference between the two communities. Like it wasn't even like 0.049, it was like less than 0.001. Like it was a significant difference between the two communities in our data set. So we're really seeing these hunter or harvester preferences throughout the whole data set, which makes sense. That's where we're getting our samples. So if we assess the two communities in the tissues, so muscle, skin, and liver is much higher than the other two tissues, which is to be expected. If we assess that as per usual, there is a big difference between all tissues, where Tuck in the West has the most or higher mercury concentrations than in Alviat, which lines up with all the previous literature. So as per usual, combined all the ages, the sizes, this is what we're seeing. So let's take a look at the skin, or makdak. Lengths combined, so just comparing males in Tuck to males in Alviat, there's no difference in mercury concentrations, but in the males, there is, where Tuck, as expected, has higher mercury concentrations than Alviat. If we look at the length bins, so we're comparing 300 centimeters to 300 centimeters in both, no difference in females, but there is a difference in males. So that's skin. Let's move on to muscle. Lengths combined, same situation. There's no difference in female mercury concentrations between the two communities. In males, it is higher. But if we compare those length bins, so apples to apples, there's no difference in mercury concentrations between males or females in muscle tissue at all. So in the muscle, we're seeing some difference there already. But the most exciting thing, I think, is the liver concentrations, because that's what that paper is referring to. Liver is really widely used as our continuous data set. So length combined as per usual, Tuk, way more mercury than Alphabet. Okay, to be expected. If we look at age bins in the females, there's no difference between mercury concentrations and between the two. If we look at the median, again, our Tuk data set is really heavily skewed. So that's why we looked at median. There's no difference in mercury concentrations between the two communities when we look at the median, but there is differences in the mean. But if we look at the length bins, there's no difference in mercury concentrations between the two communities in both sexes. So this is making us look at this historical data set differently. And so these observed total mercury trends in beluga are impacted by hunter preference. So that's biased sampling, which is like going back to basic undergrad, where you're like, oh, it's a biased data set. We need to account for that in our statistical analysis. But if we don't necessarily know that there is a cultural or local preference compared to other communities, we might not know to address for that positive bias. And looking at those mercury concentrations in the liver, we are overestimating total mercury concentrations in the ISR. So this kind of reflects a need for meaningful engagement and understanding of local context. Tuk, as Shannon said, they have local hunting bylaws, and that's not seen anywhere in Nunavut unless you have a quota. So in Alviat, there's no guidelines on what you should choose or why, but in Tuk, there is. They really encourage you to harvest the bigger whales. So that might be impacting what we're seeing. We don't fully know yet, but we just know that there is a difference between preference between the two communities. So we just looked at the same data set with different, I guess maybe a cultural lens and with some really fun stats thrown in there. So it's, I guess, important to maybe step back and see the big picture. Whew, with that, I'm going to catch my breath and we'd be happy to answer any questions. This was, again, with a lot of people and a lot of funders, but we'd be happy to answer any questions. Thank you.